Alright, welcome back to Mr. P Helps with Algebra. This is U4T3, lesson number 3. We're going to explore our third way of solving quadratic equations, which is using this is the fourth way. I take that back because we have graphing, we have zero product property, we have square root method, and this is the quadratic formula. So we're going to use the quadratic formula in order to find the answers. Well, actually here in the first video, we're not going to find the solutions just yet. I'm going to break this down into two videos. And the first video, we're going to do just to finding the discriminant. So this is the formula. This is negative b plus or minus square root of b squared minus 4ac divided by 2a, and I might have even done a competition of who can say it the most amount of times in 30 seconds in class. But this part right here is special. What's inside the radical is called the discriminant. And there's a reason why we have a word for this part of the equation, because this discriminant, I hope I spell it right, M-I-N-A-N-T, the discriminant is basically the part that tells you how many answers an equation has. Because if you get a discriminant that happens to be positive, then that means the square root of that number, square root of a positive number, as we explored in the square root method, square root of 25 is both 5 and negative 5. So the square root of any positive number, whether it's a perfect square or not, will always have two answers. The square root of a negative number will always have no answers, because no number times itself is ever going to be a negative. And then the square root of 0 is the only thing that's left, would be 0. That's the only answer you can possibly get when you do the square root of 0. So those are the only three ways you can get different amounts of answers. So like you've seen in the graph in like video number 1, you can see that a parabola can either cross the x-axis twice, it can cross once, or it can cross not at all. So those are the three different sets of ways you can have answers for quadratic equations. Oh, there, perfect example right there, what I just said. So we've got a parabola that never hits the x-axis, so this has no answers, or no roots, or no zeros. Those are all the same thing, solutions. This one is only going to hit once because the vertex is on the x-axis. That's the only answer. And then this one's going to hit twice, so therefore it has two real answers. Now, you'll learn in Algebra 2 that there can be imaginary answers, but these are all real answers. So b squared minus 4ac is the discriminant. So when you say it's greater than 0, then what you're really saying is the discriminant is positive. Positive have two roots, negatives have no roots, and when it is 0, then it's going to have exactly one real answer. So we've got a nice little cartoon here. You might have seen this on the internet before. So pi is telling imaginary number that to get real because it's imaginary, it's not real, and then I is telling pi to get be rational because it's irrational. All right, so we're going to focus on just the discriminant, which is the b squared minus 4ac. That's just the part inside the radical. That is called the discriminant. So if somebody asks you what's the discriminant, just use this part of the formula. B squared, b in this case is negative 2. So negative 2 squared minus 4 times a, which is 6, times c, which is negative 3. All you got to do is plug that all into the calculator. Negative 2 squared is 4. Negative 4 times 6 is negative 24. Times negative 3 is positive 72. So now we do our simple addition. That tells us that the discriminant is 76. Now, what that tells us is that this equation has two real answers. It could have some imaginary answers as well, but we do know it has two real answers because 76 is a positive number. A in this case is negative 2, B is negative 1, and C is negative 1. B is negative 1, so that's negative 1 squared minus 4 times A, which is negative 2, times C, which is negative 1. Negative 1 squared is 1. Negative 4 times negative 2 is positive 8, times negative 1 is negative 8. Let me just double check that. Yes, that's 8, and that's negative 8. So 1 minus 8 is negative 7. Since the discriminant was negative this time, then this is going to have no real answers. It might have imaginary answers, but it has no real answers because the quadratic form is either too high and never hits the x-axis, or it opens down and it's too low and never hits the x-axis. All right, A in this case is negative 4, B is negative 4, and C is 5. So that's negative 4 squared minus 4 times A times C, which is 5. Negative 4 squared is 16. Negative 4 times negative 4 is 16. 16 times 5. Ooh, caught me off guard there. So what is that? That's 80. Okay. So 80 plus 96. I'm sorry, 80 plus 16 makes 96. And since the discriminant is 96, that means it's going to have two real answers. All right, now this question, let's see. A is 5, B is 1, and C is negative 2. So that's 1 squared minus 4 times A times C. 1 squared is 1. Negative 4 times 5 is negative 20. Negative 20 times negative 2 is positive 40. We now know the discriminant. Okay, I wrote 41 because the discriminant is 41, and that tells us that it has two real answers. This one also has two real answers because it's a positive discriminant. This one, A is 1, B is 5, C is 2. So 5 squared minus 4 times A times C. 5 squared is 25. Negative 4 times 1 is negative 4 times 2 is negative 8. 25 minus 8 gives us 17. And that's also going to have two real answers because it's a positive discriminant. All right, question number 6. A is 2, B is 5, C is negative 4. B squared minus 4 times A times C. 5 squared is 25. Negative 4 times 2 is negative 8 times negative 4 is positive 32. So it looks like we get a discriminant of 57. So this also has two real answers. Now we didn't have any examples that had 0. So we had nothing with one real answer. That could happen maybe perhaps in these questions. Find the discriminant of each equation and state the number of imaginary and real numbers. Now I'm going to stick with just real numbers, and I'm not going to do imaginary solutions because that's more something that you're going to do in Algebra 2. Now what you should notice about all of these questions that makes them different than the previous page was the fact that none of these are equal to 0. You must solve the equation equal to 0 first in order to put it in the standard form. So I got to add 10, add 10. So I got to add 10 to both sides. So that gives me 9n squared minus 3n plus 2. Now that I've done that, now I can do negative 3. So that's b squared minus 4 times a times c. Negative 3 squared is 9. Negative 4 times 9 is negative 36. Times 2 is negative 72. Now, negative 63 is going to have no real solutions because it's a negative discriminant. All right, so first I got to add 6 to both sides. Negative 2x squared minus 8x minus 8. And then b squared. So that's negative 8 squared minus 4 times a times c. That's going to give me negative 8 squared is 64. Negative 4 times negative 2 is positive 8. Positive 8 times negative 8 is negative 64. All right, so it looks like for the first time we've got a discriminant of 0, which means this is going to have one real solution. Okay, because the square root of 0 is 0. There is no other answer. That's the reason why it has only one solution. 9m squared plus 6m. Subtract 5 from both sides makes this 1. So we can do 6 squared minus 4 times a times c, which is 1. 6 squared is 36. Negative 4 times 9 is negative 36 times 1 again is still negative 36. And look, again, we got a discriminant of 0. So once again, we got one real answer. So what we didn't get before, now we're getting a lot of here in this case. So in this question, we got quite a bit to move. The A term is already on the left. The B term is on the wrong side. So I need to move the B term by changing it to its opposite. So that becomes negative 8a. And the C term is also on the wrong side. So that becomes positive 4. B squared. So that's negative 8 squared minus 4 times 4 times 4 again. Negative 8 squared is 64. Negative 4 times 4 is negative 16 times 4 again is negative 64. And yes, it looks like we got a discriminant of 0 again 3 times in a row. All right, number 11. Got a lot to move here. The b term's on the wrong side and the c term's on the wrong side. So negative 9b squared, that's already fine, plus 8b, that's the opposite, minus 8, that's also the opposite, equals 0. 8 squared minus 4 times a times c. All right, let's see what we get. 64. Negative 4 times negative 9 is positive 36. 36 times negative 8, 24, 288 minus 288. Okay, so that becomes a positive. That becomes back to a negative. Minus 288. Well, I know that that's going to have no solutions. No solutions, because I know 64, you can do that in your calculator, 64 minus 288, and that's going to give you a negative answer, so it has no solutions. This one's negative x squared minus 6x minus 9. All right, so now that I've set it equal to 0, now I'm ready to solve. So that's negative 6 squared minus 4 times a times c. Negative 6 squared is 36. Negative 4 times negative 1 is 4. 4 times negative 9 is negative 36. It looks like we got another discriminant of 0, so therefore it has one real solution. Homeworks. All right, so it says to do any 5 problems on the back. I think I've gone over a lot of these questions. I'm going to make a second video, and on the second video, which is going to be like lesson number 4, it's going to be doing not just finding the discriminant, but it's also going to be finding the actual solutions. So when you're given standard form like this, you should actually be able to find the actual roots themselves by using the quadratic formula. All right, so we are done with discriminants. Discriminants are b squared minus 4ac divided by 2a. Remember, you don't have to memorize the formula, but it probably would be helpful if you did. That's the reason why we do the whole 30-second competition. All right, thanks again for watching. Please give it a like if it helped you learn anything about discriminants and the quadratic formula, and subscribe if you haven't done so already. Thanks. Have a great day.